I do hope that you can clear up what you have to do for this particular task. So I'm going to share with you uh, the task number 5. Okay. All right. So this is task number 5. Okay. So task number 5 is about material balance and equipment. Okay, material balance and equipment, and it is referring to your main plant actually. Okay, the whole that you cover for the whole plant. Okay, and your task is about to calculate the material balance for the main operation unit. Okay, and we have decided that for material balance, you're going to focus on separation unit only. So that separation unit can be the same as the common name, which is called distillation, gas absorption, or maybe liquid extraction. Okay, because you have learned this particular unit in the last semester subject, which is CHE 246. Therefore, this is the time for you to apply back what you have learned in separation process, which is to design the unit that you have learned. Okay, so whatever that you have learned in separation processes, for example, for distillation, you have learned how to design the quality of your product by determine the purity of your top product and maybe the purity of your bottom product. Okay, so you have decided when you learn CHE 246, you have learned when you are given that your volatile component, which is component A, will be recovered at the top of the column, which is 99% purity, 90% purity. So this involves the design. Okay, this is also involved design. So design the quality of the product that you would like to have. Okay, next you learn about to determine the height of the column, to determine the diameter of the column. That would be about designing the column, but it's also involved the sizing of the column. Okay, so you have learned about these things already. Okay, and then at the same time you learn how to do the mass balance of the given equipment. So that's why in this part I would like you to have only material balance that you have in the equipment that you have chosen. No reaction. Okay, no reaction. Okay, so we go one by one. Okay, so this assessment is only 10%, but this will reflect the rest of the task later. Okay, so first you need to calculate the material balance. So you have to know what you have in the given unit operation that you want to do the balance. Okay, and we have chosen that. So the one that we have chosen is the one that you draw for the P and ID diagram. Okay, if you have find out that you have chosen the wrong one, maybe you assume you have chosen the wrong one, you can always consult with me first before you change your mind of selecting the equipment. Okay, so bear in your mind, so we are referring to only mass balance without any reaction. So no reactor, in this particular part. Okay, all right. So the objective is to make sure that you can calculate the mass balance or material balance of the overall main operation process. Okay, so the material balance is only for the equipment that you have chosen for your P and ID diagram. Okay, from the calculation, students then will use the data to proceed doing the sizing of the main operation unit. Okay, all right, so I will explain about this. Finally, the report of your calculation and sizing will be submitted. Okay, that is one thing that you should know. Okay, all right, students are required to submit a detailed report showing calculation. So you need to show your calculation, sample calculation, okay, and the rest of the calculation can be made using Excel. So you learn about how to use Excel, you can use Excel. So if you don't know how to use Excel, you can always, let me know, just let me know whether you know how to use Microsoft Excel or not. If you don't know, maybe I can show you how to use the Microsoft Excel. Okay, so showing the calculation used to determine the material balance of each process stream and one major operation unit dimension sizing. So meaning that when you choose your equipment, there must be a major stream involved, which involve the inlet to the equipment and the outlet from the equipment. So that is called major process stream, okay, or major operation unit that you have. So you need to clear out these things, because when you are dealing with the process stream, it's involved the sizing of the unit operation that you are talking about. So in this case, if I were to choose one example, let's say you choose a distillation column, or maybe you call it fractionation column, all right? So bear in your mind, there are many names given to your separation unit, but you have to back to the basic. What is the common name given to that particular unit? So for example, you can have the name of maybe the ethanol unit or column or whatsoever, but the name is actually distillation column. Okay, same thing with the gas absorption column. So you have separator, for example, they use the word separator, but the name is actually gas absorption column, or maybe the distillation column. Okay, so get to know your column, or get to know your major operation unit very well. Okay, now, so when you determine the material balance of each process stream and one major operating unit dimension sizing, so this will reflect on what would be the original size of your equipment actually. Okay, so you just do the balance first based on the estimation of the flow that you have for each streams. Okay, and then you have to determine the purity of your product. Okay, how much recovery that you are expecting to have. Okay, so normally we're going to have maybe 70%, 80%, 90%. So it must be rational, and you must have a justification of having that particular percentage of recovery of your product. Okay, so when you have that, so you're going to keep that one in your mind, that whatever it is, okay, what you can control is only the inlet stream. Okay, what you can control is only the inlet stream. Okay, or maybe you can control the retention time that you have the materials in the column. So maybe the contact between the liquid and the gas plays important role. So you would like it to have more contacts in that particular color. Therefore, you introduce the recycle stream so that most of the product that you're going to recover will be recycled back in the column, okay? Or you can have a reflux that you have. So that is another design if you're talking about distillation, okay? Even the reflux ratio also involve involved in the designing of your column. So the purity that you decide is the design properties that you would like to have. A reflux ratio, also the design that you're going to have. Even though the inlet stream, which is the feed to your equipment or to your major operating unit, is also a control parameter that you're going to have. So for, let's say, for distillation, the condition of your feed can also be designed, meaning that you can control the feed. The feed can be in liquid form, can be in vapor form, can be a mixture of vapor and liquid. I hope that you still remember what you have learned, okay? So those condition of the feed is also the design involved in for your particular equipment, okay? So remember, okay, any question? Okay, if you have question, you just switch on your mic, yeah? Okay, so again, the inlet that you have, the inlet stream that you have can give you the design of your equipment, can contribute to the design of your equipment, okay? The outlet, which is your product distillate, the purity of your distillate also represent the design of your column. Same thing with the reflux ratio, because all those things you can control, okay? You can control all those things, okay? So what can't you control? You cannot control the number of trays or the number of stages in the column. You cannot control, but you can still determine first what would be the number of tray involved if you have one condition of the feed, and then reflux ratio and the purity of your product, okay? So you can calculate the theoretical number of trays that you have, okay? So therefore, if the number of trays that you have is, let's say, 100 trays, which is impossible for the distillation column, okay? It is impossible. So normally you have about 30 trays, okay? So this is the moment how you determine that you need more than one distillation column. So you might want to introduce 3 column later, okay? So this is what's involved in the design, okay? All right, so let's say you have a gas absorption, same thing. You learn about how to determine the number of trays, and at the same time, you learn about how to design the recovery of your of your product. And then at the same time also, I guess you can determine the diameter and the height of the column. Okay, ada satu lagi, solvent. All right, another one is about the solvent. Solvent also plays important role in designing your column. Okay, so you need to know what happened in that particular process. Okay, so that's why when you talk about what will be accessed, okay, you can see that you need to explain again briefly on your PFD. So briefly explain the process again and the purpose of this operation unit. So focus on your separation unit only, okay, on the unit that you draw for your P and ID. But this time you need to explain the process. So I give you already the task in the PFD, how you describe the process. So you can redo this one and upgrade the information for task number 5. Okay. Highlight the location of the operation unit in the plant PFD. So this is what you have to do. Just take the image of your whole plant PFD that you have in task number 1 or task number 1, right? Okay, and then you just draw a circle or a block to represent that will be your equipment. Okay, so this is what it means. Highlight the location of the operation unit in the plant PFD. Okay, and then ensure the plant PFD is updated accordingly. So meaning that you need to include the reboiler line, which will give you to the utilities facility, condenser line, and reflux drum. So you need to include that in your plant PFD. Okay, all right. So based on that, now you can see where this reboiler line comes from, and then where this condenser line comes from. Okay, so that must be because condenser needs water. All right, so it must be come from the utility. For the reboiler, maybe it's involved steam. Okay, steam line. All right, and then you might want to have reflux drum. Okay, with you, meaning that you just store the materials in the drum. Okay, so get to know about this one. So whatever that you think you must add, you have to add in this particular task. Okay, but not much calculation involve reboiler or condenser or reflux drum. Okay, now let's proceed to mass balance calculation, which is what this task is all about. Okay, so mass balance calculation, proceed with backward calculation to determine the mass flow rate of all major operation unit. Okay, so you know that now your equipment is in between or at the middle part of your plant PFD. Okay, at the middle part. Okay, so because it is at the middle part, so you need to do backward calculation. Okay, backward calculation. How backward calculation? Okay, you have decided how much product that you would like to produce. Okay, the product is the exit part. Okay, so you should know how much product that you would like to produce for your plant. So I have given you some example before. Let's say you want to produce 1,000 kilogram mole of, let's say, ethanol or ethylene or benzene. Okay, so you have decided to produce that one for your plant. Okay, so this comes the backward calculation. So you need to have 1,000 kilogram, okay, of product, let's say, at your distillate. 1,000 kilogram mole of product at your distillate. So now, how much feed that you need to make sure that you have for your column? Okay, so you have to figure out how much feed that you have to give you that amount of product. Okay, so you have to go backward. All right, so you have to go backward. So now you know how much feed that you need to have for your particular equipment to give you 1,000 mole of product. Okay, but again, your feed must come from the previous equipment. Okay, that include the raw materials that you need to have before it flows into your selected separation unit. Okay, So this means that you need to go backward again, and backward again, and backward again. Okay, because you should know. And still, the feed that you have for your selected equipment, okay, must have certain composition. Okay, and that composition maybe comes from the reactor that you have before. Okay, so you have to know that reactor will undergo, you're going to have chemical reaction there, and that reactor will produce a product because of the reactions involved. So that's involved the chemical reaction. So you need to explain what is produced from the reactor, okay, what has been distributed along the stream until you get to your feed stream for your equipment. Okay, so that is actually to give you some ideas on how much a raw ingredient do you need to get your product. So that is the things that you have to figure out. Okay, but okay, you don't have to do the mass balance on the reactor. Okay, you don't have to. Okay, let's say you can see the second point here. Okay, proceed with backward calculation to determine the mass flow of all major operation unit, maybe reactor, distillation column, mixer, and then use appropriate assumption to proceed with your calculation. So you need to have, if you have some difficulty on determining the mass balance that you get, okay, for your equipment because of the reactions that's involved before the flow that you have for your feed to your equipment. Therefore, you are allowed to make some assumption. Well, let's say you're going to assume that the reaction that takes place in the reactor will give you a complete reaction. Okay, so you're going to get a certain amount of product come out from your reactor. Okay, and then the balance is based on the chemical reaction that you have. All right, so by having that, you can simplify the information that you have or the calculation that you're going to have. Okay, so whatever it is, you have to begin from your column, go backward one by one. Okay, go backward one by one until you get your raw materials feed into the process. Okay, any question? Tak ada.
Tak ada lagi.
Tak ada lagi. Okay. Macam biasa. Okay. So kena faham tu dulu.
Saya nak tanya soalan. Saya Hafawati. Saya nak tanya soalan. Contoh kan, kan tadi Miss kata from column yang kita nak, then go backward one by one kan. Contohlah kalau macam equipment tu macam compressor. So material balance tak payah letak kan dalam ni, just letak material balance on separation unit kita je kan.
Okay, material balance memang pada separation unit saja, tapi dia bergantung pada yang previous punya equipment. In case that you need to know what are the composition for your separation unit.
So maknanya yang kita cari untuk each equipment tu tak payah include dalam report, betul tak?
Yeah. Okay. Maksudnya
tapi still kena buat lah kan untuk kita tahu composition dia. Okay.
Yeah, so please include the assumption that's involved. Okay, macam like what I mentioned just now, you assume that complete reaction. Jadi senang lah nak kira. Maksudnya macam tu. Okay, and then you know what kind of materials that you get after that. Okay, kalau dia masuk ikut just macam condenser saja, tak perlulah. Kan? Dia cuma ubah your chemical phase only. Dia tak ada melibatkan material balance kat situ. Okay, yang kita nak fokus sekarang ni ialah material balance untuk separation process. Ya, separation process. Macam you ada mixture of A, B, C. Tapi you nak A pisah daripada B, C. Contoh. Ataupun you nak pisahkan A daripada B, C. Kemudian nak pisahkan B daripada B, C. Macam tu. So that's the concept that we want you to have. Okay, so the focus actually on your on your separation unit. That's your focus. Okay.
Thank
All
you.
right. And okay, you're welcome. All right. Then, so you boleh proceed lah. Maksudnya you can proceed. Okay. Make appropriate assumption. Maksudnya what is the proper assumption to be made? Okay. Macam saya kata tadi, kita assume. Assumption kita ialah kita nak assume purity, contoh assume purity of product dekat distillate adalah 90%. So what happened? Itu je. So you use an assumption dan you juga assume bahawa you punya, maybe you boleh assume you punya tray tu adalah 25 trays, contoh kan, 25 trays. Tapi bila you assume you punya trace 25, you tak dapat purity 99, contoh. Okay, so you tak dapat purity yang you nak for your product, 99% of let's say A from B plus C. Okay, so you kena adjust. So macam mana? Kalau I nak 99, I tak dapat guna tray yang memang dah ada, jadi I kena tambah tray sepatutnya. Okay, tambah tray. Tapi tambah tray is too much. So this time, bila you nak buat dimension of your unit, you kena be logic. So you find the information, how tall is the column should be in the industry? How tall is what is the height that normally used in the industry? Okay, paling tinggi berapa height dia? You kena tahu. Jadi you takkan bina equipment, you takkan guna equipment yang tinggi melebihi apa yang selalu ada dalam industri. Itu yang kita panggil good practice. Okay, good practice. Maksudnya, kita refer to the industry, biasanya industry practice macam mana? Can we improve that? Okay, kita boleh improve. Okay, tapi kita learn from industry. Because industri dia dah operate lama dalam bidang-bidang tu. Jadi dia tahu keperluan untuk sizing ni sebenarnya. Kalau you demand yang lebih tinggi, mungkin dia kata not possible because too high, cannot be maintained. Maintenance is hard to be handled. Then memang tak boleh lah. So you kena introduce more, few numbers of column. Dia maksud macam tu. So yang you dapat reference daripada internet tu, it doesn't mean that dia guna satu je column. Maybe dia guna 2, 3, 4, 5, kita tak tahu. So you need to do the calculation because you yang determine how much product yang you nak. Ingat ya, for this chemical engineering, chemical engineering plant design, this is just a design. Belum beli lagi alat tu. Belum beli. Jadi sebelum you beli, you kena design macam arkitek. Dia draw dulu. Saya nak draw macam ni. Saya nak plan rumah saya macam ni. Saya nak rumah saya setinggi 30 tingkat. Arkitek buat. Tapi dia tak boleh lulus lagi. Dia kena study bagi orang yang professional to look through. Pernah ke ada rumah 30 tingkat? Contoh kan. Kita duduk macam saya duduk dekat Dungun. Tiba-tiba saya buat rumah 30 tingkat. Tak pelik ke? Kat atas tanah, banglo saja. Rumah 30 tingkat sampai atas. Ada lift lah sampai 30 tingkat tu. Okay. So, you must get some information kat sini sebenarnya. Okay. Proper ke tak proper buat benda tu? So, normally berapa tingkat yang kita buat? Biasa macam tu je. Okay. So, ingat. You are designing, ada orang lain pula yang akan build your equipment. Fabricate your equipment. You design. based on the chemical process that you are designing that you would like to produce. Tapi siapa yang buat column tu? Engineering lain. Okay, so you tahu proses dan you kena tahu berapa tinggi you nak, berapa tray you nak, tapi bukan you yang bina benda tu. Jadi kena collaborate juga dengan bidang-bidang lain. So that's why you need to find information. Okay. Alright. Then sizing calculation, use appropriate equation and assumption to give the dimension of the chosen major operation unit. So I allow you, saya allow okay. You boleh guna method yang kita belajar dekat semester 4 dulu. Dalam separation process. Semua method, McCarthy ke apa-apa method tu, you boleh guna with the assumption pun you boleh guna. Okay? Tapi, if you are to use other equation, boleh guna equation itu dengan syarat you cite kat mana you dapat equation itu. Okay? Sekarang ni, my theory senang saja. Sebenarnya, kalau you ada programming simulation, kita tak suruh you kira pun. You masuk je data, you tahu berapa size you punya column. So that is called simulation. Okay. Tapi kalau you ada jumpa kat mana-mana equation dalam buku ke apa yang you rasa senang nak guna, you are allowed to use. But you need to explain where you get this particular equation dan tunjuk macam mana you guna equation tersebut. Okay. So far, saya cuma accept what you have learned before sahaja. Okay. But maybe you ada ayah tu yang terror dah. Yang ajar you benda-benda ni. Okay. So dia ada formula. Cari references and prove it to me that this is the equation that you get from the reliable sources. Itu je. Okay. And then lastly, conclusion, illustrate dimension by drawing a simple diagram of the chosen operation unit. Maksudnya you kena draw lah berapa tinggi dia, berapa diameter dia. You draw saja benda tu. So far you tak ada material design lagi. Tak masuk kat sini tentang material design. Dia cuma involve sizing sahaja, sizing calculation. Okay, so ada apa-apa soalan lagi? So, saya hope you faham lah apa berlaku supaya you boleh proceed. So tentang backward calculation ni memang you kena buat. Okay, memang you kena buat. So backward you kat mana sebenarnya? Okay, mungkin depan distillation, depan unit yang you nak guna tu belum lagi ada produk yang you nak. Jadi you kena backwardkan dia sikit supaya you tahu berapa produk sebenarnya yang berada pada you punya unit. Dia macam tu. Okay, any question? Tak ada Okay. Alright, so saya hope you nak tanya, boleh tanya dalam group senang tanya dalam group instead of tanya personally dekat saya based on you punya group kecil-kecil tu. Terus tanya dalam group besar. Senang. Jadi you tanya, saya jawab, semua orang dengar. Soalan yang you tanya mungkin orang lain boleh guna nanti. Okay? Alright. So, ada apa-apa soalan lagi? Semua clear? I stop dulu sharing. Okay. So, saya ada berapa orang partisipan ni? 40 je. Tak ramai kan? Maksudnya ada kawan-kawan awak yang tak join lah. Okay, so you determine siapa yang join, siapa tak join supaya you faham apa yang berlaku. Okay. Alright. So saya nak dengar, dah okay ke tak ni? Saya nak tamatkan ni.
Miss. Sekejap nak tanya satu lagi soalan. Yang untuk introduction tu, briefly explain the process tu untuk the whole process ke yang PID process
Untuk the whole process tu?
Maksudnya, the whole process
Kan dia kata process of this operation unit. Operation tu je. You punya yang you pilih tu.
Maksudnya PID tu je lah.
Ya, yang gambar, yang equipment pada PNID diagram tu.
Okay, Miss. Thank you, Miss
Okay.
Sita.
Alright. Lain? So that's why dia ada suruh minta you update PFD tu. Kalau ada apa-apa masalah, you kena update. Because you kena tunjuk condenser dekat mana, boiler duduk kat mana. Kalau ada drum, contoh lepas keluar daripada distillate tu ada drum kan. So you kena tunjuk lah drum tu duduk kat mana. You kena lukis betul-betul lah. Bukan arrow je macam kita buat schematic diagram tu. Tak boleh. So this time you kena lukis, kena tunjuk drum tu duduk kat situ. Okay. Alright. So ada lagi? Kalau tak ada boleh cakap okay je.
Miss, okay je Miss.
Ya.
Kalau ikutkan pada task 3, Miss kan ada suruh buat mass balance juga kan?
Pada?
Mass balance. Untuk grup kami, Miss suruh buat mass balance for the certain equipment. So maksudnya dekat task 5 ni, we just need to choose the separation unit punya mass balance je lah kan?
Saya tak apa dengar sangat, tapi saya cuba translate balik apa awak cuba cakap. So awak nak tanya saya, mass balance tu untuk satu unit?
Maksudnya separation unit punya equipment sahajalah kan?
Ya.
Okay, Miss.
Kalau you ada 3 unit pun sebenarnya, ada 3 separation unit, contoh unit tu sama je. Let's say 3 tu distillation column. Tapi you buat satu je.
Alright.
Okay. Lain? Ni masa nak tanya ni, nanti tak sempat nak tanya dah. Kita jumpa 2 minggu lagi ni.
Cuti Miss layan tak soalan?
Awak tahu tak awak cuti, pensyarah tak cuti.
Okay, Miss.
Awak je cuti, pensyarah tak cuti ya. Kecuali pensyarah ambil cuti. Itu pun tak boleh cuti. Pensyarah siap kena datang office lagi. Dah tak ada PKPB dah, kena PKPP pula dah. Pergi office lah jawabnya. Okay, lain? Okay, so far so good. Saya tak ada masalah.
Untuk yang conclusion tu yang cakap yang lukis tu kan?
Conclusion? Dah habis lah tu maksudnya.
Yang lembaga lukis tu.
Okay. Conclusion?
Kan maksudnya tu kena lukis dekat satu yang maksudnya dari tu lukis dekat satu app yang macam lukis betul kan?
Awak nak pakai Visio pun boleh. Lukis kat Visio tu berapa tinggi dia, berapa lebar dia, berapa thickness dia. Tak perlulah thickness sebab dia tak sebut pun nak suruh thickness tu. Dia nak dimension je.
Just tinggi je lah kan?
Estimate? Mana boleh estimate?
Tak. Maksudnya just tinggi je lah kan? Just tinggi je.
Tinggi, diameter. Yang pernah belajar. Kalau biasanya kita kena tahu tinggi dengan diameter. Itu je.
Thank you, Miss.
Sebab nanti bila you buat costing, diameter tu akan represent the area of your tray. Jadi area of the tray ni ada price. Kalau area tu kecil, price dia murah. Kalau area tu besar, price dia mahal. Contoh macam tu. Okay? Sebab kalau tray dia kecil, mungkin dia punya bubble cap tu quantity dia sikit je. Tapi kalau you punya area of the tray tu besar, quantity of bubble cap tu banyak, maka costing dia mesti lebih tinggi. Macam tu je. Okay? Okay? Alright. So ada apa-apa sebenarnya macam ni je. You buat appointment je dengan saya. Your group tu buat appointment saya. Jadi bila saya respon, saya kadang-kadang lambat respon sebab saya ambil masa untuk fikir bila saya nak buat ni kan. Nanti cepat sangat respon nanti mungkin janji pula. Okay, so you just give me time untuk saya respon. Okay? Alright, so dah azan dah ni. Saya rasa that's all for today. Ada apa-apa nanti you do your group discussion dulu and then come up with your calculation sikit-sikit ke, and then you tahu apa progress you nak buat. If you stuck with something, just come back to me. Okay? Nak jawab pakai message. Kalau sikit-sikit tak apa. Kalau banyak-banyak saya tak nak lah jawab dekat message tu. Jumpa je lah sekejap. Macam tu je. Okay? Alright, thank you very much. So all the best for your study. Jumpa lagi nanti. Assalamualaikum.
Thank you, Miss.
Waalaikumsalam. Thank you, Miss.
Thank you, Miss.
Thank you, Miss Ita. Waalaikumsalam.
Welcome.
Miss.